We'll proceed in pseudo multivariate calculus. Okay, mind blowing. Pseudo multivariable calculus, the topic in which we are pursuing the discussion. Pseudo multivariate calculus. We have to write our mathematics in terms of simple mathematics only. And in mathematics, generally we see length. If we see length, then length we have to replace with the length vector that we have invented. That is the idea. Okay, that is it. Okay, is it that only what we are talking? Yes, means length vector what we have invented, that came from a fundamental, that whenever we see multiplication of two items, A into B, where A is function over B, and then in that case A into B is actually A into D of B, that becomes integral calculus. When multiplication of two items where one item is dependent upon another item, then multiplication turns into integral calculus integration. A into A into B, A into B, where A is dependent upon B. Now B has a length, right? B may be 10. A into B, where B may be 10. Now when I'm writing it as integral calculus, then it becomes A into D of B. A into D of B. Now it signifies it is integral calculus. In that sense, whatever the B value was, if I said 10 or it was 20 minus 5, because it is talking about a range, then what will happen to B? A will have some value, A into D of B. Then one integration sign comes into the picture. Wherever whatever the B was, that comes here. Now B is from B1 to B2. Okay, A into D of B. This is called integration. This is called integration. Integration in the sense that multiplication is replaced. Integration in the sense that multiplication is replaced by the integration. Similarly, if there is A by B, where A is function of B, then it will be replaced by differentiation. dA by dB. A by B means per unit change in B brings how many unit of change in A? That is A by B. Okay, 5 by 20 by 5. 20 by 5. If 20 corresponds to one entity and 5 corresponds to another entity, then 1 unit of change in another entity brings how many unit of change in the entity? That represent the numerator. That is division. If it is algebra and numerator is dependent upon denominator, then it will become differentiation. That's it. This is what we are doing. Length vector. We are into deep discussion of the length vector. Length vector is that if I have to find the length of a curve, length vector means oh, oh, oh. Length vector means if I have to find length of a curve, if I have to find length of a curve, if I have to find length of a curve, if this is x-axis, then this is the curve. What is the length of the curve between origin and any point x comma y? Now to find the length of the curve, we take an example where this curve is a straight line. In that sense, what is the length of the curve from origin to any point x comma y? This length is same as if I represent this as a vector and then calculate the magnitude of the vector. The length will be same. 0 comma 0 to x comma y, the vector will be xi plus yj. The vector will be xi plus yj. Magnitude is x square plus y square root, that will be the length. Now then we saw that if I take that example in a curve where origin and x comma y, there are 2 points. If I connect through a vector, then we will get the length of the straight line, not the curve. Okay, in that sense, what is the curve? Difference between curve and a straight line. Difference between curve and a straight line is, for the straight line, if I take any y by x anywhere, in the straight line, any point if I take y by x anywhere, It is same where in curve y by x, this is x-axis, y by x at any point is different. Point to point it is different. So we represented xi plus yj the vector in form of y by x, that become I plus y by xj bracket close into x, or someone can also represent as x by y I plus j into y. It is up to the requirement and we have done it. We have done in other way also, y by xi plus j into, I'm sorry, x by yi plus j bracket close into y, whatever it is. If I take I plus y by xj bracket close into x, now this is a pure form of, it will take form of calculus. Y by x, y is dependent upon x, y is a function over x, and it is division. It is a good case of differentiation. And then I plus dy by dxj full bracket close into x. This term into x is multiplication of two items, where first item, that is I plus dy by x, dy by dxj, is dependent upon the right hand side x. In that case, this is the candidate for multiplication will turn into integration. That is I plus dy by dxj bracket close dx. This is called length vector. If I calculate magnitude of this length vector, that is 1 square plus dy by dx whole square root into dx, it will give the length of any curve vector or a straight line, whatever it is. But if I do dot product of this length vector with a force vector, then it will give the work done. If I do the cross product of this length vector with any length vector, it will give the area vector. Make sense? If I do dot product of area vector with the length vector, it will give the volume. If I do the cross product of area vector with another area vector, it will give the weight vector, fourth dimension. It is miraculous. It is miracle. Length vector is something that works everywhere. Now, in that sense, we are trying to prove that length vector indeed it works very well everywhere. Then what about the path independence when we calculate the work done under a force vector field? Like Earth gravitational pull is a force vector field from the Earth. If this is the Earth, down is the Earth, then Earth vector field is like this. Force vector field is like this. Can you prove that force vector field is like this? Okay, it is like this. Just leave it. It is like this. Anyway, if someone sees the Earth as a round sphere, if someone sees Earth as a round sphere, then Earth gravitational pull is from all the sides. Okay, in that sense, the Earth gravitational pull is minus gmm r vector by r to the power 3. Capital G is the gravitational constant, m is mass of the Earth, and another m is the mass of the entity that is going towards Earth into r vector. If this is Earth is a sphere, if Earth is a sphere, then r vector, it is a spherical coordinate system. So in 3D, r vector is all along going to the center, r vector by r to the power 3, where r to the power is the distance from the center of the Earth. That is the force through which Earth is attracting something. Okay, in that sense, but if I take like this, then Earth is very big in front of me. It is like a flat. So the gravitational pull will be straight everywhere, parallel. But it is actually not true. If Earth is a small ball, small sphere, then gravitational pull will be radial. It will go like this. It will make one radial and another radial will make an angle. It will not be parallel the way we are thinking. Okay, that is the Earth gravitational pull. Okay, but if I see in the local linearity, then it seems like a parallel line. Anyway, that is the scenario. Earth gravitational pull is path independent. Path independent in the sense that work done, if this is the path of an item which is moving along the path from this point and going to the origin, the item is moving from this point. This point is x comma y. Consider this is x axis and this path is y equal to x square. In that sense, item is moving from a point called 4, comma 16 and it is going towards origin. How much is the energy that is generated by the earth to make the item move from 4, comma 16 to 0, comma 0? If something is moving, then someone is working on it, someone losing energy. Then why it is moving? Okay, if it is in my hand and if it is moving like this, then energy is going from my body. I am losing the energy. If I just leave like this and it is moving, then someone is losing the energy. Earth is losing the energy. Nothing is for free. So Earth is losing the energy. Earth is losing energy through its force field. And Earth force field is path independent. Path independent in the sense that if there is a point called 4, comma 16, an item is moving along this line and it is going to origin, then work done is only dependent upon the begin point, that is 4, comma 16, and end point 0, comma 0, not on the path it is taking. What are you talking about? Not on the path. Path can be a straight line also. A straight line connecting 4, comma 16 to origin. There is a straight line. Through a straight line, item is moving like this. Or through a curved line, item is moving like this. Or through a staircase, item is moving like this. Whatever you do, Earth will lose energy only depending upon the begin point and end point. This is called path independent. Now, path independent proof that we have right now in mathematics is that the net energy that is released by the earth making item move from point A to point B, that is called work done, is integration of from point A to point B. Force field, that is the earth force field, dot product with the, in our terminology, with the length vector, dot product with the length vector, because that is the, this is what why we are bringing pseudo mathematics. Pseudo calculus means write everything in a mathematical form only. If I talk in calculus, then I will say, consider that if force field is vector, then in the differential part of integration has three parts. One is called limit, one is called integrand, and one is called differential. The differential part has to be vector. Force vector dot product with the differential part has to be vector. Now then only dot product will happen. Now people, they go and get lost in the differential part. Now what is differential part? Differential part is d of xi plus yj. What is xi plus yj and what is d of? Generally in book it is written that work done by the earth is the force gravitational force, that is capital F vector, that is F1i plus F2j plus F3k. Okay, if I see earth gravitational force, then it is minus gmm, that is constant, and then r vector divided by r to the power 3. If I put in rectangular coordinate system, Cartesian coordinate system, r vector will be resolved as xi plus yj plus zk divided by r to the power 3, that is x square plus y square plus z square to the power 3 by 2. Then if I say I have earth gravitational force as capital F, that is equal to F1i plus F2j plus F3k, then F1 is x by x square plus y square plus z square to the power 3 by 2. F2 is y by x square plus y square plus z square to the power 3 by 2. And F3 is z by x square plus y square plus z square into 3 by 2, power 3 by 2. That is F1, F2, F3. The earth gravitational force field, that is capital F dot product with the length vector, is the net work done. This is the normal mathematics. This is what people know. Earth gravitational pull should be a numeric vector and displacement should be a numeric vector, where F1, F2, F3 of the earth gravitational pull should be a number, and in that sense displacement should be also be a number. Means I 1 2i plus 3j, that is the displacement. Force field is 5i plus 6j. Both are numeric vector. Numeric vector means a straight line. Force vector is a straight line, and through which it is force vector. Force vector is a straight line. Force is a straight line, and force is applied on an item that is moving along a straight line. One item is kept here, and it will bound to move in this direction. Force is in this direction. This is force vector. Because of the force vector, item is moving from here to here in this path. How much is the energy involved? In that case, integration from this point to this point, force vector field dot product with the displacement vector. That is the what? This is the normal mathematics. Or if I don't do integration, I'm sorry, if I don't do integration, then force field dot product with the displacement vector is deduced from point A to point B. If I have point A and point B, then B minus A is the vector. Okay, A can be x1 comma y1 and point B can be x2 comma y2 in xy space, in xy plane. In that case, vector is x2 minus x1I plus y2 minus y1j. Okay, I believe it makes sense. Now, in that sense, force vector field dot product with the displacement vector is the net work done. But it turns into calculus when force vector field is algebra, like the way we told about the Earth gravitational pull, xi plus yj plus zk divided by x squared plus y squared plus z squared to the power 3 by 2. And the displacement vector is not a straight line. Displacement is happening in a curve fashion. In that sense, this is algebraic vector. That is I plus dy by dxj into dx. This is called algebraic vector typically. Anyway, the concept is that from our principle, the net work done is force vector dot product dot product with the displacement vector or length vector is the net energy. That is force vector, that is F1I plus F2J plus F3K dot product with our vector form. Our vector form right now it is in XY plane only. Then it will come as I plus dy by dxj into dx. Okay, if it is in xyz, then it will become I plus dy by dxj plus dz by dxk into dx. Anyway, just do dot product of these two and compute the integration limit from point A to point B in the space where A is x1, y1, z1 and B is x2, y2, z2. Simply you get the result. No need to put your head against a wall. Okay, this gives the pure straightforward result. Anyway, but right now, if in the book it is written like work done is force field dot product with d of xi plus yj. This is what written in every book. What is d of xi plus yj? People they do not know. That's the problem with the mathematics. One level, people understand the mathematics. Beyond that, they think it is a matter of examination. We have to fetch a number from the examination and we have to get some job here and there. That's it. So energy calculation as per calculus is force field dot product d of xi plus yj. Okay, but from our calculation, force field dot length vector is the energy as per any mathematics. Force vector dot length vector distance vector is the energy. Now length vector is I plus dy by dxj bracket close into dx. This length vector can be substituted anywhere where length is required. Simple. Rather than force vector into d of xi plus yj. What is xi plus yj? No one understands. Why it is d? No one understands. Simply do it. Anyway, now the concept is that can we prove the path independency? But it is proved. People have proved that it is path independent when f vector dot d of xi plus yj if this resolves into another algebraic function gxy. If I break it, f vector fi plus f2j plus f3k dot with, or let's remove the k right now, fi plus f1i plus f2j dot product with xi plus yj. If I do this, then it becomes f1 dx plus f2 dy, f1 dx plus f2 dy. If someone calculates this integration and it comes as an algebraic function called gxy, algebraic function called gxy, and okay, that is one thing. A person deduced gxy. What is the work done? Work done is force field dot product with d and in braces xi plus yj. If it is 3d, then xi plus yj plus zk. Okay, now compute this. The force vector field is F1i plus F2j. And here d of xi plus yj. This becomes dxi plus dyj. Dot product will give F1 dx plus F2 dy. If this integration leads into a result called gxy, g is a function and in braces x comma y. G is a function over x and y, and it happens to be that gx comma y, the partial derivative of gx comma y. If it is multivariable, if it is gx, then simple dgx by dx is the derivative of this. But derivative of gx comma y is dgxy by dx is the x component of the derivative. dgxy by dy is the y component of the derivative. So derivative of this will turn into vector. That is dgxy by dx I vector plus dgxy by dy j vector. That is the derivative. If derivative of gxy, that is the result of integration, where dgxy by dx is f1 and dgxy by dy is f2. It is not necessarily that this will happen every time. But if it happens, then it proves that f1, the result of gxy, is only dependent upon f1. dgxy by dx, that whatever is coming is f1. Then gxy is and dgxy by dy is f2. Then it proves that the result that gxy what we are getting is only dependent upon f1 and f2, not on the d of xi plus yj. We are calculating work done and force vector field dot product with the d of the path, that is xi plus yj. But if we are able to get the result only from force field, not on the path at all, and then it is called path independent, because whatever result we are getting, it is only dependent upon the force field. So if I am getting the result at gxy, then I have to set the limit a to b, that is the integration limit a to b. So net result gxy is only dependent upon force field and limit, that is begin point and end point. So if I have a force field and begin point and end point, with these two items, begin point and end item is one item and force field is another item. These two only, if you are able to calculate the energy, then it is completely path independent. From point A to B, it takes whatever path it comes to its mind, doesn't bother. So to prove it mathematically, we first calculate the energy, that is F vector dot product with d of xi plus yj, and that resolves into gxy. If d of gxy by dx is f1 and d of gxy by dy means partial derivative of gxy, partial derivative with x is f1 and partial derivative of g with y is f2, then gxy is only dependent upon f1 and f2, and the net result will be from a to b, that I have to set, means on the begin point and end point, not on the d of xi plus yj that we are saying the path. This is called path independent. So path independent is proved technology when we take the path as d of xi plus yj. Okay, we proved it in a way that how it is possible. So please watch our previous video. So we proved in a way that if I say d of xi plus yj, we started our discussion that can we prove it through our length vector. Our length vector says force vector dot product with the length vector is the energy, and force vector dot with the length vector what we have introduced, that is I plus dy by dx j into dx. Okay, anyway, if what is the path dependency? This is under question mark. What is path dependency? Path dependency is where we break the y. If I see in our calculation, what is a path? If I talk a path from this point to this point, then this is the path. If I take another path from the same point, if this point is 4, 16, If this point happen to be 4 comma 16, then one path is y equal to x squared. If this point is 4 comma 16, then one path is y equal to 4x. There is another path that is x equal to 4. That is one path, and then another path is y equal to 0. I can take this path and this path also to get to the same 4 comma 16 to 0 comma 0. All different paths are different when we have y and x relationship. If I substitute y with x, then only we have different path. Like if I have a length vector I plus dy by dx j into dx, if I substitute y with the actual line, then dy by dx will start differing for different kind of line. Otherwise, if I denote it in y only, not breaking the y in terms of x, then it will be completely generic. I plus dy by dx j into dx is generic for the every path because we are not breaking y now. In that case, if I resolve this I plus dy by dx j into dx, if I break it, it becomes dxi plus dyj. It becomes d of xi plus yj only. The way people they see in the book, d of xi plus yj, and from our length vector also, if I resolve this, it becomes dxi plus dyj only. That is d of in bracket xi plus yj. This is a line vector. This is a line. This is also called line vector. This is a vector xi, d of xi plus yj. Please watch our previous video. That is how we come to a line. Line vector means a vector that is along the line. This is algebraic vector. Algebraic vector that is along that line or tangent at every point is called line vector. D of xi plus yj is a line vector, whereas xi plus yj is called position vector. From origin, if I draw a line, this is called position vector. But if I differentiate this position vector, it becomes tangent at that point. It becomes line vector. Okay. Now, idea is that it should be path independent if I am taking if I am not breaking the y. If I break the y equal to 4x, y equal to sin x, y equal to this, y equal to that. In that sense, our length vector I plus dy by dx, will start changing as per the relationship between x and y. But if I take in term of y only, then it will come as a generic length vector. That length vector belongs to any kind of curve. Now, force vector field dot generic length vector will be result will be path independent. In the sense, the result will be only dependent upon the force field. If force field is path independent, that is the concept that we have to prove. Now, our displacement vector or length vector becomes d of xi plus yj. That is written in the any of the book. This is what we have to initiate. This is called length vector. D of xi plus yj is called length vector. Xi plus yj is called position vector. These two are different. Anyway, force vector field dot d of xi plus yj. D of xi plus yj is our length vector actually originally. I plus dy by dxj dot product with dx that came as d of xi plus yj. Now this is path independent in the sense that this will come to a result, this integration will come to a result that is gxy, where gxy has come only from the force field, not from the d of xi plus yj, that is the length vector. But anyway, we have deliberately brought this point as d of xi plus yj because this we want. If it is path independent means it will work for all the paths. Path independent means result will be same for all the paths. That is called path independent. Path independent is only dependent upon begin point and end point. That is true. But other statement is also there, that is path independent should be same. The result should be same for any kind of path. For any kind of path, the line vector is d of xi plus yj. For a particular path, then y I have to replace with the formula. Y equal to sin x, y equal to 4x, y equal to x square. If I change y to x, flip the y to x, then it becomes path specific. Otherwise, it is path independent. Anyway, this formula is path independent. F vector dot d of xi plus yj if I get the result in term of x and y, not only in term of x, I can get the result in term of x only, not in the y. If I flip the y in term of x, then 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 the gxy will, I'm sorry, the result that is coming from the integration. Can you try one? If force vector field is xi plus yj, xi plus yj is the force vector field, dot product with d of xi plus yj, y equal to x square. Consider y equal to x square. Then it becomes dxi plus d of x square j. That becomes 2x dxi. Now here force vector field is xi plus yj, or in simple term, force vector field dot with d of xi plus yj becomes x dx plus y dy. Okay, because force vector field is xi plus yj. X dx is alright, where y is x square, dy is 2x dx. It becomes 2x to the power 3 dx. Full become x plus x to the x plus x plus 2x to the power 3 bracket close dx. Now this result of this integration, that is x square by 2 plus 4x to the power 4 by 4, this result, the integration result, will come in only in x. This may be path dependent, this may be path independent, because we have broken the y. This is, I would say, this is path dependent, because we broke the y. If I don't break the y, then the result of the integration, if I break the y, the result of the integration will come as a function of x1, gx, only gx. If I don't break the y, then result of this term will come as gxy. Okay, so for the generic path where y I am not breaking, for the generic path f vector dot d of xi plus yj, result is coming as gxy. If I break it into a path, then it will be gx, where y is broken, already broken. If I bring in gxy, then y exists. Now when y exists, the net result is called gxy, that is also called potential function, potential energy function. Now, if I calculate the partial derivative of gxy, that is dgxy by dxi vector plus dgxy by dyj vector, because it has two components, and this I and j, dgxy by dxi vector plus dgxy by dyj vector. Okay, if it is matching the f1i plus f2j, f1i plus f2j, then looks like gxy is only dependent upon f1 and f2, because we can get back gxy from f1 and f2 only. Okay, people talk in different way also. The net result is gxy from a to b. Gxy a to b, that is the net result. That is same as g of b minus g of a. As per the calculus, g of b minus g of a. G of b minus g of a, where b point can be x2, y2, a point can be x1, y1, whatever. Gb minus Ga is the net result that we are getting. G is a Gxy. B is a point in x and y. Gb minus Ga. Gb minus Ga is same as integration from a to b of differential of Gxy into dxy. Make sense? If I have any function any function gx is same as integration of differentiation of gx, dgx by dx, integration of dgx by dx is gx. If I have gxy, then it is same as integration of differentiation of the gxy. Make sense? If I have a function, resultant function as gxy, then gxy is same as integration of differentiation of dgxy, d of gxy. D of gxy integration is same as gxy. Okay, but it is dual variable. It has x and y. So differentiation of gxy will come as dgxy by dxi plus dgxy by dyj. Okay, this is the differential part. Means gx is equal to dgx by dx into dx. gxy will be dgxy by dxy. Now there are two terms, x and y. So d of xy into d of xy. Okay, dgxy by d of xy is dgxy by dxi plus dgxy by dyj. Since this is a vector, it will the differential part of the calculus that we are saying d of xy, it will also be a vector. So that will be d of xi plus yj. Now this is now we are going from the result. If I have a result that is result of f vector dot product with d of xi plus yj, if this result is g of xy, limit is a to b. If I have g of xy limit is a to b, then it is same as gb minus ga. That is same as integration from a to b. Integration from a to b, d of gxy by d of xy into d of xy. Same thing. Like gxy is same as d of gxy by dx into dx. Limit a to b. Same thing. So dgxy by dxy is dgxy by dxi plus dgxy by dyj. This is called gradient vector. Gradient vector. Derivative in multidimensional will lead to a vector. It is not that straightforward. Okay, dot product with, if it is a vector, then it will go as a dot product. Dot product of dxy, that is d of xi plus yj. This is exactly same thing that we had seen in the force vector energy calculation. Now only replacement is d of gxy by dx is f1 and dgxy by dy is f2. Means if I am going through the generic fashion where I am not breaking the y into x, then in that case we are getting the resultant of f vector dot d of xi plus yj as gxy. And in case luckily if dgxy by dx is f1 and dgxy by dy is f2, then gxy, that is the net result, is only dependent upon f1 and f2. How I can bring gx means I can bring gxy only from f1 and f2. D of xi plus yj, that is the line path, is not required. So net result what we are getting, gxy limit from a to b, this result is only dependent upon f1 and f2. Then someone would say, if we are taking we are taking everything in term of y, then it should be generic only. It should be path dependent, not independent. Not true. Idea is we have to get gxy only from f1 and f2. What is f1? F1 is dgx by dx. F2 is dgx by dy. If I get gx from f1 and f2 only, okay, then it is not dependent upon d. The net integration is force vector dot product d of xi plus yj. That brings gxy. If I get gxy only from f1 and f2, not through gxi plus yj, then gxy is path independent. In the sense, force field is path independent, not dependent upon a path. But anyway, whatever we are doing, it is through generic path only, so that we get gxy. Anyway, now let's consider that I have a force field that is y cos x plus sin x. I'm sorry. Force field is y cos x I plus sin xj. This is the what assignment we gave. Actually, idea was to calculate this, to do this with the other proof also. One proof that we have done right now, we started with the generic dxi d of xi plus yj without breaking y. With a generic path, what is the net integration? The generic path net integration is gxy. If I take generic path, and one thing. Second thing, if I take generic path and force field is path independent, not necessarily that force field will be path independent. Our calculation, we started with a generic path, not required that force field will be path independent. If force field is not path independent, then force field f dot dxi plus yj, okay, we cannot get gxy, because gxy, I'm sorry, I would rephrase this. We have started a discussion where we are trying to get the gxy, that is resultant of the force vector dot the path independent line vector. If we are making a discussion force vector dot product with d of xi plus yj, this is called path independent line vector, because this d of xi plus yj is valid, this length vector is valid for any path. If this path is path independent, then net result gxy should be path independent. But if I have taken the integral, I'm sorry, the energy calculation is force vector dot length vector. Length vector is I plus dy by dx j into dx, that resolve into d of xi plus yj. If length vector we have taken as generic, I mean that is path independent. If I do dot product with the force vector has to be path independent. If it is path independent, then net integration I can get a gxy, and that is limit from a to b. Okay, because gxy a to b will resolve into gb minus ga. That is same as gxy a to b is same as integration from a to b dgx by dxi plus dgxy by dyj dot d of xi plus yj. Means if I am able to get gxy, then it is path independent. Why it is path independent? Because gxy dgxy by dx equal to f1. Means gxy is only dependent upon f1. dgxy by dy is f2. Means it is only dependent upon f2. Means I can get back gxy only through f1 and f2 for any generic path xi plus yj. But not necessarily it will happen like that. We will try. If force vector is cos xyi plus sin xj, this is the force vector. We will try to get the gxy through the force vector. Now we have d of gxy by dx equal to f1. Means f1 dx equal to gxy, because we are taking and gxy equal to f2 dy, dgxy by dy equal to f2, dgx by dx equal to f1. As per our calculation, I am not saying anything about path independence. We have taken line vector or our length vector as a generic vector. But this is what we have seen. This is the basic calculus. I am not talking about path independence. Okay, so net energy calculus is force vector dot the length vector. Length vector is in term of x and y. Length vector we have taken generic vector for any curve, because y we have not broken. Now this brings the result at gxy. Now we know gxy is same as integration of dgx gradient vector of gxy d of xi plus yj. Same thing. In that sense, f1 equal to dgxy by dx and f2 equal to dgxy by dy as per the fundamental. Let's not proceed with the path independence. In that sense, gxy equal to f1 dx and gxy equal to f2 dy. Is it really happening in every case? This is what we are saying. Now consider f1 is y cos x and f2 is sin x. Now in that sense, dgxy by dx equal to y cos x. Then gxy equal to f1 dx integration. Okay, f1 is y cos x. Integration of y cos x dx is y sin x plus any function of y. Any function of y. I call it cy. C in brackets y. If I have y sin x plus cy, that is equal to gx, then dgx by dx equal to y cos x plus 0. This is what we have as f1. I'll do reverse thing. I'll try to get gxy through f1. Then gxy equal to integration of f1 dx. That becomes y sin x plus any function over y. Now this we got the gx, that is y sin x plus any function over y. If this dx, if I differentiate with dy, then it becomes f2. Now let's differentiate it with dy. Y sin x dy becomes sin x. Sin x plus differentiation of a function cy equal to f2. F2 component is sin x. Sin x gone. differentiation of cy equal to 0 means cy is 0, cy is not there at all. Then what is the gxy net energy we are getting, potential energy we are getting? The gxy is we are getting is y sin x, means y sin x, that the net energy we can get only from f1 and f2. Path is not required. Okay, we will try with another one. Let's see that force vector field is y sin x, y sin x I plus sin x j. We took y cos x I plus sin x j, force vector field. Consider it is y sin x I plus sin x j. Now dgx by dx equal to f1, gxy equal to integration of f1 with dx. Y sin x integration is y minus cos x plus any function of y, that is gx. Now if I differentiate the gx with y, it will be f2. Now if I differentiate with y, that is minus y sin x, it will become minus y cos x, minus y cos x plus differentiation of any function of y only plus cos x. I'm sorry, plus plus sin x. Then differentiation of cy, different, we had earlier minus, I'm sorry, I'll start again. I have a force field that is y sin x I plus sin x j. That now this force field is like that. F1 is y sin x and F2 is sin x. Now we have gxy. Gxy dgxy by dx equal to F1. Gxy equal to F1 dx. Okay, F1 dx plus some function over y only. So that if I do dgx by dx, F1 dx becomes F1 plus some function over y will become 0. Now in that sense, F1 is y sin x, integration will be minus y cos x, minus y cos x plus any function over y. Now if I differentiate this, that is gx now minus y cos x plus any function over y, cy, if I differentiate this dgx by dy, it becomes f2. f2 is sin x. Now in that sense, differentiation will become minus cos x plus derivative of cy equal to sin x. Now derivative of cy will become sin x plus cos x. But if now to get the cy, I have to integrate sin x plus cos x with dy. And everything must be y only, because cy is a function of y only, not cos at all, not x at all. So cy, the cy here, the cy is only cy, the derivative of cy equal to sin x plus cos x. If I take antiderivative of which means if I integrate, then cy equal to integration of sin x dx plus cos x dy. This should result in function of y only. There should not be any x. So this is contradicting what we had thought. Means for vector for force field, that is y sin x I plus sin x j, there cannot be any gxy. There cannot be any gxy for which we have dgxy by dx equal to f1 and dgxy by dy equal to f2. That is not possible at all. People can try. Force vector field is y cos x I plus y plus sin x j plus y plus sin xj also. People can try. Let's try. Y equal to, I mean force field is y cos x I plus y plus sin xj. Then gx equal to integration of f1 plus function over y. That is y sin x plus y sin x plus any function over y. Now if I differentiate it with y, it will become f2. Then y sin x, if I differentiate with y, it becomes sin x. Sin x plus dcy by dy equal to, now equal to y plus sin x. Sin x gone. Only y remained there. Now we have dcy by dy equal to y. cy equal to integration of y, that is y square by 2. Okay, that is y square by 2. Now we have gxy equal to y sin x plus y square by 2. Y sin x plus y square by 2. If I differentiate with x, then it becomes y cos x. If I differentiate with y, if I differentiate with y, then it becomes sin x plus y. This is what we had. Means if I take a generic path, that is length vector is I plus dy by dxj plus into dx, where I'm not breaking y. Through that I am getting a resultant at gxy. Then gxy is path independent, because we have taken path independent path only. This proof is not there in the book. People, they try with something, they do not understand what is path independent. Path independent is path independent is also when we try all possible path, that is generic path. Path independence, if vector field is path independent, force field is path independent, then we can take all path, that is generic path. Generic path means why we will not break. This is better proved by our fundamental that length vector is I plus dy by dxj into dx. If I break it, it becomes dxi plus dyj. If I take out d, then it is d of xi plus yj. This is line vector. If I say xi plus yj, then this is position vector. D of xi plus yj, this is line vector. This line vector is for any line. Now this is generic. Now in that sense, f vector dot d of xi plus yj, this will resolve into an integration in a result that is called gxy. If we are getting able to get gxy, then this is anyway path independent, but it does not happen. Through generic way, it will not happen. Through non-generic way, it will happen. If I switch y into x, then integration is possible. If I don't switch, then integration is not possible, because if I am get gx is possible. That is the result. That is possible. Gxy is not possible. If I get gx, then gx is same as dgx by dx into dx, integration from a to b. That is in x only. But if I get result at gxy, this is, if I get result at gx, then that is path dependent. For a particular y-x relationship, I am getting gx. Gx will be different for different y-x relationship. Y equal to 4x, different gx I get. Y equal to sin x, different gx I get. But if I get result at gxy, it is for every path. But if I get gxy, then gxy is same as dgxy by dxi plus ddxy by dyj in dot product with dxi plus yj. Then in that sense, dgxy by dx should be f1, dgxy by dy should be f2. But this does not happen with all the force field. This is what we saw. Okay, this is the way that we can prove our force field is path independent or not. Okay, it works well with our length vector. We will try another proof. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. We are